Hi students, how are you all? I hope you are all fine and safe at home. This is K. Venkatesan from Department of Physics, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Today I am going to introduce a new topic, Physics in relation to technology and society from 11th standard Physics, first unit, Nature of Physical World and Measurement. See, we are going to discuss one by one, Physics in relation to technology, Physics in relation to biology, Physics in relation to mathematics, Physics in relation to astronomy, Physics in relation to geology, and the last one is Physics in relation to psychology. Now I am going to see one by one. The next one is measurement. My dear students, what is the meaning of measurement? Comparison of any physical quantity with its standard unit. This is called measurement. See, in this measurement, we will discuss briefly in this section. The next one is physical quantities. Definition of physical quantities. The quantity which can be derived from which laws of physics are described are called physical quantities. The physical quantity example, length, mass, time, temperature, volume, area, density, etc. In these physical quantities, classified into two types. The first one is fundamental quantity, next one is derived quantities. Fundamental quantities, very important, two more questions. Define fundamental quantities. The quantity which can be measured, which cannot be measured any other physical quantities, this is called fundamental quantities. The fundamental quantity defined, the fundamental quantities are quantities which cannot be explained in terms of any other physical quantity. This is called fundamental quantities. The fundamental quantities are 7 types. For example, length, mass, time, temperature, luminous intensity, amount of substance, like that. The next one is derived quantities. The derived quantities, next 2 more questions. The derived quantities can be expressed in terms of any other fundamental quantities. This is called derived quantities. Example, area, volume, density, force, energy, etc. This is called derived quantities. So, here fundamental quantities and derived quantities derivation explained in this section one by one. The next one is units. Same, my dear students, what is the meaning of units? The same concept. The comparison of any quantity, that means any physical quantity, with the standard value or standard reference, that is called units. The units classified into two types, fundamental units and derived units. The quantity which can be measured by using fundamental units, this is called fundamental units. The quantity which can be measured all other physical quantities is called derived units. The next one is type of measurement. There are 3 types of measurements. The first one is FPS. That means FPS system is nothing but FPS stands for foot, pound and second. In this system, we are using olden days. The next one is CGS system. CGS system is nothing but CGS stands for centimeter, gram and seconds. 3 basic quantities for measuring length, mass, time. The next one is MK system. The MK system stands for mass, that means meter, kilogram and second. There are 3 quantities for measuring length, mass, time respectively. The next one is very important, SI system. SI stands for System International Unit. See, SI stands for System International Units. In this unit used by all the scientists and engineering all around the world. So at that time, in the system commonly known as metric system, since 1960, it has been officially known as SI units. SI stands for System International Units. In this SI system of units, some of the units and special functions and some formulas were developed and implemented. The General Conference on Weight and Measures in 1971. This is a very familiar system, SI system. Now we are going to following this system only, because this system only all around the countries, all the countries following this system only. This system is nothing but SI system. See, now physics in relation to technology and society. The next, physics in relation to chemistry, physics in relation to biology, physics in relation to mathematics, physics in relation to astronomy, physics in relation to geology, physics in relation to oceanography, and the last one is physics in relation to psychology. Now see one by one. Physics in relation to technology and the society. See, the technology is the application of the principle of physics for practical purpose. Not only that, physics and technology can both together impact our society directly or indirectly. For example, the basic law of electricity and magnetism leads to the discovery of wireless communication technology. And also, the basic law of physics, the launching of satellite into the space, has revolutionized the concept of communication. See, the wireless communication technology nowadays very essential in our all the techniques and all the departments. The next one is the launching of satellite into the space has revolutionized the concept of communication. Invention of physics principle, semiconducting material like that, electronics, capacitors, insulator, all the electronics materials, invention of physics principle, nuclear energy, laser, computers, semiconductor, insulator have completely changed the thinking and living style of human being. Physics in relation to chemistry. In our physics principle, the study of structure of atom, radioactivity, radioisotopes, X-ray diffraction, etc. such as studies in chemistry to arrange the element in the periodic table on the basis of their atomic number. See the periodic table. And also in our physics principle, the study the structure of atom deals with nuclear size, nuclear volume, nuclear energy, radius of the orbit, various orbit, energy of the orbits, everything explained in our physics principle. The next one is, in our physics principle used in chemistry, interdisciplinary branches like quantum chemistry, physical chemistry or play vital role or important role here. See, next one is physics in relation to biology. See, biological studies are impossible without microscope. The microscope design in our physics principle only. In this microscope, it is able to see clearly internal structure of human cell and animal cell. Not only that, the invention of electron microscope. See, this is an electron microscope. The invention of electron microscope, it is used to see the smallest virus like that. Nowadays, coronavirus and HIV virus easily see by electron microscope. And also the physics in relation to biology, in physics concept, invention of X-ray discovered by W.C. Ranjan. How to form of X-ray? When a fast moving electron suddenly strike to target material, form of X-ray. It is a accidental ray. See, in this X-rays are used for diagnostic purpose in medical field. And also radiotherapy, that means radioisotopes like Gopal 60. This Gopal 60, it is used for treatment of human and animal cancer. The next one is physics in relation to mathematics. My dear students, we know that concept. Physics is a qualitative and quantitative science. So physics is most closely related to our mathematics for various application purpose. The next one is physics in relation to astronomy. Physics in relation to astronomy. Astronomical telescope and radio telescope, it is used for motion of the planets and motion of the heavenly bodies in the sky. Using physics principle, radio telescope and astronomical telescope. The next one is physics in relation to astronomy, the physics in relation to geology. Here in our physics principle, diffraction techniques used to geology. For example, to study the structure of various rocks. And also the diffraction techniques are radioisotopes. We know that radioisotopes, carbon C614. See, carbon C614 star. It is used to study to find the age of the rock and fossil and age of the earth. See, age of the rock, fossil and age of the earth using radioisotopes like that carbon C614. The next one is physics in relation to oceanography. In our physics principle, the oceanographers to find the physical and chemical properties of the ocean. For example, current speed of ocean, salinity of the ocean, and finally temperature of the ocean. The next one is physics in relation to psychology. All the psychological interaction can be derived from physical process. For example, in our brain, it is related to underlying wave particle dualism. So physics in relation to biological process. Next topic, measurement. We know that concept. Measurement is nothing but, see, this is the basic measurement: length, mass, time. There are three methods. See, what is meant by measurement? The comparison of any physical quantity with its standard unit is known as measurement. See, any one physical quantities, to measure any standard value, we need some standard value. So we need 1 kilogram rice. We need some standard reference value for measuring purpose. Very important question, define measurement. The measurement means comparison of any physical quantity with the standard unit known as measurement. The next one is physical quantity. Quantity that can be measured in terms of which the laws of physics are described are called physical quantity. Example of physical quantity: length, mass, time, temperature, area, density, volume, like that, etc. These are all physical quantities. The physical quantities are classified into two types: The first one is fundamental quantities, next one is derived quantities. Fundamental quantities is nothing but, see, quantities which cannot be expressed any other physical quantities. This is called fundamental quantities. Very important 2 mark question, dear students, listen. Fundamental quantity is nothing but quantity which cannot be expressed in terms of any other physical quantities. Examples are length, mass, time, temperature, etc. The next one is derived quantities. The quantities that can be expressed in terms of fundamental quantities. It's known as derived quantities. The derived quantities, example, area, volume, velocity, acceleration, force, etc. See one by one. We will discuss one by one. And also, see, next one is different type of measurement system. Different type of measurement system. The first one is FPS system. FPS stands for foot pound seconds. In this system, following British engineering system, there are 3 fundamental system. FPS, foot pound seconds. It is used to measure length, mass, time respectively. The next one is CGS system. Is nothing but C stands for centimeter, G stands for gram, S stands for seconds. In this system, it is a Gaussian system. In these 3 basic measurement for measuring basic units length, mass, time. The next one is MKS system. MKS is nothing but is based on mass, kilogram, seconds. 3 fundamental quantities are measuring length, mass, time respectively. Nowadays we are going to using SI system. Sir, what is the meaning of SI, sir? SI stands for, S means system, I means international. That means SI system of unit is nothing but system international unit. In these units used by all the scientists and engineering all around the world. At that time, in these systems as commonly known as metric systems. It is since 1960. In the system officially known as SI systems. In these SI systems, we are using some notation, some formulas, some rules were developed and recommended by General Conference on Weight and Measures in 1971. The next one is the SI systems having 7 fundamental units. See, the first one is length, unit of length, meter, symbol m. There are 7 fundamental quantities: length, mass, time, electric current, temperature, luminous intensity and amount of substance. This very 1 mark question, important 1 mark question. My dear students, listen here. See, for example, SI unit of length is, say, open your mouth. SI unit of length is meter, symbol m. Next one is the SI unit of mass, kilogram, symbol kg. Next one is the SI unit of time, unit second, symbol of time second. Next, XI unit of electric current, answer is ampere, symbol A. The next one is the SI unit of temperature, unit Kelvin, symbol K. The SI unit of luminous intensity, unit candela, symbol CD. The next one is amount of substance. The SI unit of amount of substance, mole, symbol MOL, mole. There are 7 fundamental quantities. The next one is derived quantities. See, derived quantities and their units. See, area. The expression for area, length and breadth. How to measure length? Using meter scale. Here meter into, how to measure breadth? Here also meter. Here meter into meter, meter square. Unit of area is meter square. Is the correct answer. The next one is volume. Volume is formula, length into breadth into height. In other words, we are calling area into height. So here also area, that means here meter square into height meter. So meter square into meter, meter cube. So the volume of unit, SI unit of volume meter cube. Next one is velocity. What is the meaning of velocity? Displacement by time taken. The formula for displacement, how to measure? Meter only. Here displacement meter, time second. So what is the answer? Meter per second, in other words we are calling meter second inverse. The next one is acceleration. What is the formula for acceleration? A equal to velocity by time taken, or change in velocity with respect to time, that is called acceleration. Velocity is formula you know very well, meter per second, time here meter second power minus 2. This is the acceleration. The next one is angular velocity, angular displacement by time taken, angular displacement SI unit radian time second inverse. So radian second inverse, the unit of angular velocity. The next one is angular acceleration, angular velocity by time taken. This is the angular velocity with respect to time taken, angular velocity radian time second power minus 2. That means velocity meter power minus 1, here also time. So we get the answer radian second power minus 2. The next one is density. Density you know very well, mass by volume. What is the unit of mass? The SI unit of mass is kilogram divided by volume. We know that volume, unit of volume meter cube. So kilogram meter power minus 3 or say kilogram per meter cube. This is the unit of density. The next one is momentum. Momentum is nothing but mass into velocity. See, mass into velocity. Unit of mass kilogram. What is the unit? Velocity. Velocity already we know that velocity equal to meter per second. So apply here where momentum kilogram meter second power minus 1. The next one is moment of inertia. General expression mass into square of the distance. We are going to measure mass here kilogram, distance square meter square. So kilogram meter square, SI unit of moment of inertia. What is the unit of force? One more question. SI unit of force. So Newton sir. So in other words we are calling, see here SI unit of force is mass into acceleration, that means MA equal to F, you know very well, force equal to MA. So mass unit kilogram. The next one is acceleration meter second power minus 2. In this 2 value we are calling Newton. That means kilogram meter second power minus 2, in other words we are calling 1 Newton. Otherwise we are calling 1 Newton. Okay, next one is pressure. General expression for pressure, force by area. What is unit of force? Newton, area meter square. That means meter power minus 2. Newton meter power minus 2, in other words we are calling 1 Pascal or Pa, P-A, Pa. That means Pascal, the great scientist Pascal. The next one is energy. Listen my dear students, energy equal to work. Very important. Energy equal to work. What is the formula for work? Force into distance. The same value energy. Force into distance. What is the unit of force? Here Newton, distance meter. So Newton meters, in other words we are calling 1 joule here. It's very important expression. Newton meter, in other words we are calling 1 joule. The next one is impulse. Impulse expression force into time. Force unit Newton, time seconds. So Newton second, the unit of impulse. That means SI unit of impulse. One more question. See your study materials one by one. All the derived quantities. Very important one more question. My dear students, read carefully this expression. These very important formulas. Keep your mind. The next one is surface tension. General expression. That means formula for surface tension force. That means surface tension force per length, per unit length. What is the unit of force? Newton. How to measure length? Meter. Newton per meter. See here, Newton per meter, in other words we are calling Newton meter inverse. The next one is moment of force. In other words we are calling, see, this is also very important. Moment of force, torque. In other words we are calling torque. General expression force into distance. What is the unit of force? Newton. What is the unit of distance? Meter. Newton meter, the SI unit of torque. See, next one is electric charge. Here Electric charge is nothing but, see here, what is the formula for current? I equal to Q by T. I equal to Q by T. We need charge only. Replace Q equal to I into T. What is the unit of current? Ampere. Unit of time? Seconds. Here, see here, ampere per seconds, unit of electric charge. Are you understood? See here, we need electric charge only, but we know the formula, current I equal to Q by T. What is the formula for SI unit for charge? We need charge only, SI unit of ampere, current ampere into time. So here, ampere seconds, unit of electric charge. The next one is current density. Here also very important, current density. Current density, general expression, J equal to I by A, current passing through the unit area. So J, current density. What is the formula for SI unit for current? Ampere, area, meter square. See here, ampere per meter square is the unit of current density. See, are you clear? Very simple concept. Magnetic induction, the expression for magnetic induction, force by current into length, unit of force Newton, current into length, current ampere, that means ampere inverse, length meter inverse. So unit of magnetic induction is nothing but Newton, ampere inverse, meter inverse. This is a very very important expression, important formula, don't forget my dear students. Next one is next. See, next one is measurement of length. My dear students, what is the meaning of length? Length is a distance between any 2 points in space. This is called length. Say, my dear students, SI unit of length is, say, open your mouth. Yes, meter. SI unit of length is meter. Very good. Now, new concept, macrocosm and microcosm. Sir, what is the macrocosm and microcosm? Macrocosm deals with a large object like galaxy, planets, like that, stars, sun, all the heavenly bodies and the distances which constitute a macrocosm, which means deals with the large objects. This is called macroscopic, that means macrocosm. The next one is microcosm. The microcosm is nothing but it can be deals with the smallest object like bacteria, electron, proton, neutron, pion, cation, chemeson, all the smallest particle. It can be deals with their distances too small. It constitutes a microcosm, which means smallest world. Deals with the smallest world. This is called microcosm. The next one is measurement of large distance. Sir, how to measure the distance between the two planets? Using our meter scale? It is impossible. How to measure? Direct method. For example, meter scale. We are using meter scale, no? So only it can be measured 10 power minus 3 to 1 meter range only. For example, 1 millimeter to 1 meter. Okay, sir. Screw gauge having no, sir. Screw gauge. In the screw gauge, up to 10 power minus 5 meter only. And the vernier caliper range up to 10 power minus 4 meter only. Okay, sir. How it is measured the micro level, invisible particle, distance between the two atomic distance or two molecular distance. We will measure, we will discuss in this section. Okay, now I am going to explain measurement of largest distance. For example, distance between the two planets or distance from the earth from moon or distance between the any other two planets. Sir, simply to find the height of the tree and the height of the tower, how to measure, sir? At the time we are using three special methods are adopted here. The first one is triangulation method, next one is parallax method, last one is radar method are used to determine the very large distance. See, the first one is triangulation method. And also first we need some power value. Sir, factors name of symbol and factors name symbol C. This is a macroscopic value, this is a microscopic value. That means it can be deals with the large object, it can be deals with the smallest object. See, 10 power 24 is nothing but iota, symbol Y. 10 power 21 zeta, represent letter is Z. 10 power 18 exa, 10 power 15 beta, 10 power 12 tera, 10 power 9 giga, 10 power 6 mega, 10 power 3 kilo, 10 power 2 hecta, 10 power 1 deca. It can be deals with the macrocosine. The next one is microcosine, which means deals with the smallest object. See, 10 power minus 1 deci, 10 power minus 2 centi, 10 power minus 3 milli, 10 power minus 6 micro, 10 power minus 9 nano, that means nanotechnology. 10 power 12 pico, 10 power minus 15 fermi. In this level, the distance between the interatomic distance, that means the radius of the nucleus, 10 power minus 15. Femto, in other words, we are calling 1 fermi. The next one is 10 power 80 auto, 10 power minus 21 gypto, 10 power 24 minus 24 ecto. This, it can be deals with the smallest object, it deals with the large object, that is microcosine. This one is macrocosine. The next one is largest distance. I am going to explain triangulation method for the height of an object. See, let us consider an object or tree. This is a tree. The distance between the tree A and B, AB is nothing but height of the tree. Listen here. Now I am going to determine the value of height of the tree. See, the triangulation method for the height of an object. In this object is nothing but, let us consider one tree. To find the height of the tree using triangulation method. In this tree, height A and B equal to H. This is the height of the tree. This value only I am going to find out here. See, AB equal to, say what is the value AB? AB equal to height of the tree. The next one is, here the point C is nothing but point of observation. See, at a distance x from B, here BC equal to x is nothing but horizontal distance, this value known value. The next one is, at a point C you want place any one astronomical telescope. See, here place the telescope. Now I am going to find out the value of elevation. The angle of elevation, angle ACB, angle ACB equal to theta. This angle of elevation. From right angle triangle ABC, here ABC in right angle triangle, tan theta equal to, what is the value of tan theta? Here tan theta equal to opposite side by adjacent side. This is a formula for tan theta. So applying here, tan theta equal to, what is the opposite side? Theta, opposite angle AB, here AB divided by adjacent side. See, adjacent side BC, BC. Here tan theta equal to opposite side by adjacent side, opposite side. See, theta opposites AB only. Here AB, adjacent side BC. Here AB by BC. What is the value of AB? AB is nothing but AB equal to H. Here AB equal to H. So tan theta equal to H by, what is the value BC? X. We need height of the tree only. So height of the tree H equal to cross multiply X into tan theta. This is a very important formula, triangulation method to find the height of an object. See, one problem, NEET and IIT problems based on this formula. See, let us consider here one, that means tower. Let us consider one tower. The height of the tower AB, same value, AB equal to h. That value only I am going to find out here. See, height of the tower h equal to question mark. The angle of elevation theta value is given. For example, theta value, theta equal to 60 degree, for example, angle of elevation. Next one is the horizontal distance, known value b is equal to, that means x equal to 50 meter. So here to find the height of the tower, my dear students, how to measure using this formula? What is the formula? The height of the tower h equal to x tan theta, x equal to h equal to x tan theta. Substituting this two value here, h equal to, what is value x? X is nothing but 50 meter. 50 into tan, angle of elevation here given 60 degree. So h equal to 50 into, what is the value of tan 60? Here root 3. My dear students, what is the value of root 3? Yes, 1.732. Here h equal to 50 into 1.732. Multiply this two value. Height of the tower equal to, what is the value multiply? 86.6 meter. This is the height of the given tower. Okay, easy only, no? Yes. Okay, any doubts? Dear students, below this video we have attached study materials, PPT, YouTube link and self assessment test question papers in this description. Thank you.